Okay, hi and welcome to video notes. There's a little V missing here. 9.1 on adding and subtracting polynomials. Now, that sounds like a fancy term, polynomials, but it's really pretty basic. And really, we've already done it. We just called it like terms. We didn't give it an official name of a polynomial, but that's what we were working with the whole time. So if you remember like terms and combining like terms, that's exactly what we're going to kind of be going through today. We're going to add some stuff in those specific to polynomials, as in naming and couple other properties that we're going to see. So without any further ado, let's go ahead and get right down to it. You should remember at this point that a term is any type of expression that it contains a number, a variable, some type of product or operations, and it can have more than one variable. And a degree, something you should also be familiar with, is what we refer to as the exponent in a lot of cases. But a degree then is any monomial. And just to remember, and this might be slightly new because I don't know if we've called it this before, is a single term polynomial, meaning that it's going to be all multiplied or added together, kind of like A and B down here at the examples. Okay. Let's review all of that together in one quick little picture, just so you can kind of see. This would be a great thing to add down to your notes, probably put somewhere. It's a nice review of everything all smashed together. Again, let's refer to this as, well, let's start here. This is the polynomial. This whole thing together, the whole red circle, is the polynomial. Remember, it's a multi-termed expression. Expression meaning there's no equal sign, correct? Notice there's not one there. So here's one term, 3x squared. Here's another term, 2x, and 1. Those are all your terms. You could have infinite many number of terms as you wanted to, or whatever the leading degree is, and we'll talk much more about that later. Okay, so the term again, combinations of variables and operations, right? Multiplication, addition, and subtraction, all mixed into one. So there's a single term. This is actually a three-term polynomial, but what we're going to deal with in a second is a single term, so we give it a special name, monomial, and that's what you saw in the wording back there. And again, the degree is the exponent of the variable. So write that down. It would be excellent to pause and do that there. All right, let's move back and get right into a couple examples here. Now, before we do the examples, you're going to see some multivariable terms. Most of the stuff that we do with functions usually only exists with one variable. So keep that in mind. Even though you see two, most of the stuff we're going to do is just one. So in these examples that we're about to do, you won't have to reproduce this that many times. All right, so with that being said, what we're going to do here is we're going to look at these monomials, and each of these are monomials because there's only one term involved. If we added or subtracted something and put another term there, then they become different term polynomials. But right now they're monomials. So looking at these monomials, what we're going to do is we're going to look at all the different variables that could exist in them. A is something that we're going to usually do. B is something that we'll see occasionally. Okay, and if we see something like B where there's more than one variable involved, we're going to add up those exponents, but only when they're different variables. That's key. Don't do it all the time. Do not, if you have more than one term, start adding variables from different terms. Don't do that. No. Okay, that's what I'm trying to get you to avoid. All right, so with any further ado, there's a couple examples. Make sure you pause and write them down, but let's do these two. So this monomial here has one variable. We're going to go ahead and take a peek at its exponent so we can find its degree. In this case, if it's not written, we know that it's 1. So the degree for this monomial is equal to 1. Okay, looking at this one here, this has got two variables and it's in one single term. It's important to identify that. And what we're going to do is we're going to take these two terms. We're going to take the single term, but we're going to take the exponents of both of the different variables. Here's x, that's our one variable, and y is our other one. The exponent of x is 2, and we're going to add that to the exponent of the y, which is 3. And then we're going to add them together, and that's going to give us our degree of that particular monomial. Again, most of the stuff we're going to do with functions will not have that happen. And here's some other ones. Notice this is a constant, and this is, since there is no variable, x to the 0 really means 1, right? Anything to the 0 power is 1, and if we take 1 and multiply by that 4, it's just that 4. So constants do have a variable, it's just to the 0 power. Don't let that trick you. All right, so make sure you check out those other two examples. Let's scoot down here a little bit more. So here's the official definition of a polynomial. A polynomial is a monomial, or a sum or difference, just means add or subtract, right, of a couple other monomials. So we tag a bunch of them together, okay? If we put the highest degree, where does it say that? Yeah, well, it says decreases from left to right. You put the largest degree polynomial, I was going to write a number, but we're not going to do that, to the left, on the left side, and then you decrease them sequentially across to the right, that is in standard form. We've done that before. What's that look like? Well, here's a generic looking polynomial. Here's one term. Here's a second term. Pretend there's some other terms over here. Pretend that they're added or subtracted on there. If the highest degreed one's to the left and each degree goes down after that, that's standard form. Okay? So you're allowed to move these around, don't forget, by the property that we learned way back in semester one called the commutative property, which says that anything that's added or subtracted on the same side of an equal sign or in an expression can be rearranged any which way you want to. So you're allowed to move those around. So do that. That's a really good idea to do. So let's practice putting things in standard form. To do that, we have to combine all like terms. L, oh, there's a T first. There's an L. L and T, like terms. Got to combine all of those first. Once we have all the like terms combined, then we're going to move our terms around, just like we said with the commutative property, making sure our largest degree, I'm going to go up big numbers, right? Our exponent, I guess I should write that, but that would be a better, our exponent with our largest degree, our largest exponent is going to be on the right, I'm sorry, on the left here, and on the right, we're going to have our smallest exponent, or exponents of 0, constants. Woo, let's put that away. Okay, so looking at these examples, there's a couple to do. Make sure you check those out. I'm going to do this one at the end here. It says write each polynomial in standard form. You've noticed I've highlighted here. And each of these highlightings, what I'm using is colors to signify the same kind of terms, or like terms. So in this example D, you'll notice that this monomial, this term, has an exponent of 5, where this term, negative 202x to the fifth, have the same exponent. Those are considered like terms. So they need to be combined. And that's what my colors is using here. Sometimes I'll use lines or I'll use shapes for these. Like sometimes I'll use for fifth degree, I'll use a polynomial around it. Because sometimes you'll have a lot of terms to keep track of, and seeing it visually with a shape will help. Polynomials, or I'm sorry, pentagons have 5 sides. That's why I would use that one. In single degrees, like this x to the first power here, I'd use a line underneath. So any which way you'd note those, you're going to have a lot of them to keep track of at some point. So find a way to keep track so you don't forget one. That's commonly a mistake by some students. So in this case then, to get it in standard form, let's combine our like terms. So really when we combine like terms, I don't know if you remember this, all we're going to do is add the coefficients or subtract them in this case. The exponents stay the same, okay? So add coefficients, add or subtract coefficients, add or subtract coefficients, exponents same. Well, there we go. All right, so if I do that there, I'm going to end up with negative 199 x to the fifth, because the exponents stayed the same. I subtracted my coefficients, and then I'm going to add on this lower degree on the right side. So 7x. That's technically in standard form. All right, again, check out those other examples. Let's get down here to naming, though. So on naming, we can name these polynomials, and that's what we're working with here, polynomials again. We can name them 2 ways. The first way we can name them is by their degree. The second way we can name them is by terms. Just so we're clear, naming these, this is usually our number one method. Okay, we usually call them by the degree. That's usually a little bit more important to us in most aspects, but not always. And then we name them by number of terms. So this would be kind of our second to go. Sometimes we say both because it's important. So let's go ahead and get down to the naming. These are all just examples on the left here of what it would look like, an actual example of one. But if we have a degree of 0, and we talked about that a minute ago, meaning that our variable would have a degree of 0, which really just means it's 1, or 6 times 1 just being 6. That's your constant, right? That's the name of that one, constant by degree. You'll notice this one here does have 2 terms, but that's not what we're going to look at first. Right now we're going to deal with degrees. The degree of the variable to the far left, right, our highest ordered monomial, has a degree of 1. And if it's 1, we're pretty comfortable with that. We know that's linear. We actually already used the term linear quite a bit in our class. Looking at the next term here, you'll notice we've got 3 terms. We don't care about that. All we care about is this exponent, because we're still naming by degree. And if we have a 2, some of us are still pretty familiar with the fact that this is quadratic. I have to check off linear there. And 3, we're slightly familiar with, but we'll become more familiar with if it's a 3 for our leading one. And again, this is a monomial, so it has a single term. That's fine. That's not what we're looking at. We're looking at this degree of 3. If it has a degree of its largest monomial being 3, it's called cubic. And the last one that we'll look at, and there's at least one more that we weren't going to talk about, but the last one you'll see is a 4th power. And a 4th powered one, again, highest monomial to the left, has a power 4, higher than 3, higher than 1, right, is what we refer to as quartic. Minimally remember these for Algebra 2. Okay, this one, Maybe. It comes up a little bit, but really we spend a lot of our time right there. Okay, so let's talk terms. A term then, let's just redefine this before we get into this, because this first one's a little bit tricky if we don't. Let's scoot over here for a second. What's not a monomial or a term? Okay, which is kind of, I use those two together loosely. So what's not a monomial? A monomial then is a combination, I don't know if I wrote this down, I'll write it down right here, is a combination of variables and numbers. Okay, and exponents, I guess, if you want. So that's what it is. It has to have kind of a combination of both. But let's talk about these. Square root of x is not a monomial. Okay, the reason is it doesn't have an exponent that we can deal with. Really, if you want to get fancy, it's to the 1/2 power. Don't worry about that. It's not a monomial. 1 over x squared, and you're like, well, there's a variable, there's a square. We could even make it 2x squared. Doesn't matter. The problem with this is we don't like it because it's in the denominator. So that's also not a monomial. All right, looking at 6x to the negative 2, well, we know that from our prior units that the negative says to move this variable, right, and its expression to the denominator, which really means it's 6 over x squared. Again, we don't like variables in the denominator. They're a different function. Okay, so none of those are monomials, which takes us back to the first one here that I kind of disagree with. I kind of like to say that this chart, a 6 over here, actually is a monomial because I like to say it's x to the 0 power. So for me, this actually is a monomial. Okay, so looking at that then, if it has a single term like both of these here, right, we're going to refer to them as monomials. Okay, this one has 2 terms in it. Okay, that would be referred to as one term, 2 terms, and I'll even use a highlighter for this. 1 term, 2 terms. I'm going to call that a 2-term binomial. It's off a little bit. This one here is a 3-term polynomial. 1, 2, 3 terms, and if it has 3 terms, I'm going to call that a trinomial. And then this last one here, I don't have a 4th term, but we'll write one really quickly. I'm going to say 2x to the 5th plus 4x squared plus 3x plus 6. I'm going to go ahead and call that 6 a term, right? So 1, 2, 3, 4 terms. We stop calling them special names, and we start 1, 2, 3, 4. We start just saying how many terms are in them because, again, it's not super important for us. All right, so now we're done with terms. Let's flip our page over, and I'll meet you there. Okay, so we're on the back side of our notes, and what we're going to do is practice writing in a standard form and then naming it. So you can see I've got a couple examples here. Go ahead and match those. Again, this highlighted part says that I'm combining those like terms. Okay, so LT. So let's do this last example here so you can kind of see it. Again, remember what we're trying to do to get it in standard form. A highest degree has to be on the left, and all like terms has to be combined. So let's go ahead and verify if we've got like terms here. 2x is a single monomial term, right? So it's a linear term because it has a degree of 1. Nothing yet to combine it with. We're going to say this is to a degree of 0, so I'm going to go ahead and circle negative 3. That's the middle term. And then the 8x squared, I'm going to put 2 lines to represent squared, and that has no terms in here that need to be combined. So far, so good. All we have to do then is move the 8x squared to the front. Again, using the commutative property here, we're allowed to do that. This negative 3 is going to go to the end, but next we're going to write this positive 2x. And then I'm going to slap on our negative 3. Let's name it by degree first. So we're going to look at that 2 right now, and it's a 2, and we just remember that 2 means quadratic. So we're going to name it quadratic, and then we're going to count the number of terms. 1, 2, 3 terms, so it's a trinomial. All right, so now that we got that done, I'm not going to spend a lot of time on the stuff down here because we've already done this before. This is actually mainly review. This is our like terms section. So make sure you check out these examples. Again, the colors are matching like terms, so make sure you combine those first. The trick I'm going to give you here is that if there's addition between 2 polynomials, and I've got a lot of color on here, so it's hard to see. Here's one polynomial right there. Here's the other polynomial right here. If there's addition between them, you can drop the parentheses of both and just combine like terms. So you can see that was my first step here. Okay. And then I'm going to go ahead and give you the other tip, which is when you're combining polynomials, again, lots of colors, so I'm going to highlight it for you. If you've got a polynomial here subtracted by another polynomial here, this one you can't drop. Okay. Actually, there's a common mistake here. Most people only multiply the negative to the very first monomial of the second polynomial. They forget to make sure that all of the terms inside that polynomial change signs. So you'll notice that this 5x here 5x squared became a negative 5x squared, and this this negative 12 became a positive 12, along with the 7x cubed became negative. You have to switch all of the signs in all of them. Don't forget that. Very common mistake that's continually done. All right, so really I'm just going to do this last example to keep the video short. It should do both sections for you. Again, don't forget to take a second and pause and write all the rest of this down. So looking at this example here, we're going to remember to distribute this negative. So really that means I'm going to rewrite the first one without the parentheses. So negative 4m cubed minus m plus 9, dropping the parentheses because there's nothing in front to multiply to it. This negative is going to be distributed to all of these three terms of this polynomial. So I'm going to go ahead and switch all the signs here. So this becomes a negative 4m squared. This becomes a negative m. This becomes a positive 12. Now I'm going to start to combine like terms. I'm going to switch colors here so we can see it. This is cubed. So that means it's got a side of 3. A lot of times I'll do a triangle for its shape. I'm going to look for another cubed. I don't have any. So now I'm going to move down to my squareds. Squareds, I usually put 2 lines underneath. So I'm going to look for other squareds. I don't see any. I'm going to move down the list another degree, and so I'm going to move to a degree of 1. I seem to have 2 m's of a degree of 1, so I'm going to have to combine those two. And then again, my constants with a degree of 0, I'm going to wrap a big circle around them, positive 12 and positive 9. I'm going to have to combine those. So I'm going to switch colors again. I'm going to write my largest degree, which is my cubed, out front. Negative 4m cubed. I'm going to move to my squared because I know I only have one, negative 4m squared. Now I'm going to look at my linear terms. I've got a negative m. The sign that's in front of it goes with it. If there's not the one, it's positive. But if there is a sign, you take it with it. So this is a negative m and a negative m. Remember, when combining like terms, this negative really means negative 1 on both of these. And that means that I'm adding the coefficients. The exponent's going to stay the same. So this becomes a negative 2m to the first, but I'm not going to write it. All right, and then I've got 9 plus 12, which gives me 21. All right, positive 21. That's that one multiplied out and simplified. All of these show the same thing up here with the addition, even though I didn't do this one. It's just combining like terms and writing the largest degree to the left. Okay, so in review, you should be able to take large polynomials, look at how many terms there are here, and add them together and subtract them with distributive to every term. And we've also gone through the naming, so you should be able to name by degree and name by terms. And additionally, you know what standard form is now. And finally, we've got some good definition of some terms that we're going to be using throughout the quarter. All right, good job today. I'll see you in class.